Alright, this is 4-2, using the addition rule. I do not, like the book, make a distinction between addition rule 1 and addition rule 2. Addition rule 2 is the only one I want you to even use. Now, I'm going to do 4-2 addition rule plus I'm going to use example 4-21 as an example. But before we start, let's look at an example of two sets that are not mutually exclusive. When I make my Venn diagram with the two circles, there's an overlapping part that I shaded in red. That overlapping part is part of B, as I gesture at B, and it's part of A, as I gesture to A. That part is known as A and B. Now, if I want to find the probability of event A or B happening, that's equal to adding up, and I'm shading all of A right now, including the stuff that's overlapped, plus everything that's B, shading everything that's inside of B, including the stuff that's the overlap. Then I notice I just shaded the red part twice. I shaded it once for A and I shaded it once for B. So now what I need to do is subtract off the double count. The double count was the red area. Remember, I started with that area being A and B. And so because I counted it twice, I'm going to subtract it off once. Okay. From here, if we look at example 4-21, it gives us a chart of nurses and physicians where they're female and male. Now, normally when you're given charts, they don't automatically do the total for you. So the first thing I want you to do when you have charts and you're answering this type of question is use the totals. Remember, when we do classic probability, you need to divide by the total. This will also help us when we do 4-3 and we're doing conditional probabilities and statements. Then this becomes very important. So, how many nurses total as I go across my row? Well, there is 8. How many physicians total as I go across my row? I had 5. How many female staff did I had? 7 plus 3 is 10. How many male staff did I had? 1 plus 2 is 3. And my total for everything, 8 plus 5 is 13, or 10 plus 3 is 13. So now if I ask about any individual probability, what's the likelihood that a staff member is female? That's 7 out of my total 13. Or if I ask what's the likelihood that I have a physician, it's 5 out of 13. Alright, so if I'm going to answer the question in the book, find the probability of a male or a nurse, that's probability of male or nurse. That's going to equal probability of male plus probability of nurse minus the double count. So the probability of male and nurse. So let's find these things. I'm going to use 3 colors to do that. So I'm going to use green for my males. How many males do I have? I have 3 of them out of a total of 13. So the probability is 3, 13. Alright, I'm going to add to that the probability of having a nurse. Well, how many nurses do I have? Using red, I have 8 nurses, so that's 8 out of 13 for the probability of getting a nurse. Now, there's a problem. I have to take out the overlap. What do I mean by overlap? Well, the overlap is all of my males and nurses. Do we see any place on our chart that has males and nurses? Yeah, so using the blue pen, I'm circling the 1 right there under males and nurses, and 1 out of my 13 fits that category. So now I have 3 plus 8 minus 1 gives me a grand total of 10 out of 13. Notice if I had reduced fractions, not that I could have done that with 13, I wouldn't have as easily been able to add or subtract them. When you have your fractions, always leave them out of your total. Don't bother reducing. It'll make your math easier. All right, 10 out of 13. There you go.